Yes, students, in the last video we had seen how a K-map function can be used, K-map method can be used to simplify Boolean function. Today we are going to see how the simplified Boolean function can be implemented. You see, it is given that minimize the following Boolean function f of a, b, c, d is equal to sigma m of 0, 1, 2, 5, 7, 8, 9, 10, 13, 15. Now we are going to draw the K-map for this given Boolean function. Since it is a 4 variable function, we have to draw the 4 variable K-map. It should consist of 16 cells in it because 2 power 4 is equal to 16. The first two variables a, b are taken here and c, d are taken here, and the values for the variables are from 0, 0 to 1, 0, and it should follow gray code combination here so that the adjacency condition can be satisfied. Now we are going to plot the K-map. So here the given minterms are plotted as 1 and the remaining minterms are taken as 0. Then we have to group the given number of ones. You see here there are four ones are at the corner of the K-map. So those 4 ones can be combined into a quad. And similarly these 4 ones are vertically adjacent to each other, so we can form a group here also. And these 4 ones form a square and we can form a third group here. So for this first group, the variables a and c are varied for each minterm, but the values of b and d are fixed one. That is, it is a constant one. So the final term will be b bar d bar. And for G2, it is b d because a and c variables are varied in those 4 minterms. And in this third group, we are having c bar d bar as the final term because in the 4 cells the value of a and b are variables, so those variables are cancelled here. So we can obtain the final simplified Boolean function as b bar d bar plus bd plus c bar d. Since it is a simplified SOP function, we have to implement this function using AND OR logic only. So you see, the simplified Boolean function has 3 product terms here. So each product term can be implemented using AND gate. So the first term is b bar d bar. So we have to take one 2 input AND gate, and in the second term also 2 literals are present. So there also we have to use 2 input AND gate, and in the third term also we have to use 2 input AND gate. Finally, all the 3 outputs are added together to form the final simplified expression. So at the first level we are using AND logic, and at the second level we are using OR logic. So for every simplified Boolean SOP function, we have to use AND OR logic for the final implementation. And next, we are going to see another example for this K-map simplification. Here it is given that minimize the following Boolean function f of a, b, c, d is equal to sigma m of 0, 1, 3, 5, 7, 8, 9, 11, 13 and 15. So again it is a 4 variable function, so we have to draw 4 variable K-map first. This K-map again consists of 16 cells in it. The first 2 variables a, b are taken here, and third and fourth variable are taken here. So the values are 0, 0 to 1, 0. It follows a gray code combination so that the adjacency condition should be satisfied. And the minterms are 0, 1, 2, 3, 4, 5, 6, 7, and the 8th minterm should come here because these two cells are adjacent. So 8 can be written here: 8, 9, 10, 11, 12, 13, 14, 15. Now you see these 8 ones are adjacent to each other, so we can form a 8 cell minterm combination here. So this group will be D because all the 3 variables a, b and c are variable in these 8 minterms, and only the fixed minterm variable is only d. So this group gives d term, and these four ones are adjacent to each other because we can fold the K map vertically, so it can form a group, and this G2 group will be B dash C dash. Now the final simplified Boolean expression will be f of a b c d is equal to d plus b bar c bar. Now we are going to implement this using AND OR logic. You see here only one minterm or product term is there, which is b bar c bar. So for that we have to take one 2 input AND gate, and along with the output of this AND gate, D is combined and it is applied to OR gate. So the final output will be F is equal to D plus B bar C bar. In this way we can implement every SOP function using AND OR logic. Thank you.